What's up, everybody? Today is March 2nd, 2025. Today is another day for Leetcode Dailies. Hope you all having a wonderful day. We're going to go ahead and start our warm-up on Type Racer. I don't feel like I'm getting any faster, but it does help to practice every day, I suppose. A real life here, one that keeps him grounded. There about, wow, him as more than just a criminal. Rating. He drives me crazy on his best days. Have to know. Up to. Wow. Talk about a large number of typos. Look at them all. Alright, whatever. Anyway, let's go ahead and check out the problem of the day. Is it going to be easy or hard? Easy or hard? 2161. Partition array according to a given pivot. I haven't done pivots question in a while. You're given a zero-indexed integer array nums and an integer pivot. Rearrange nums such that the following conditions are satisfied. Every element less than pivot appears before every element greater than pivot. Okay. Every element equal to pivot appears in between the elements less than and greater than pivot. Okay. The relative order of the elements less than pivot and the elements greater than pivot is maintained. More formally, consider every pi, pj, where pi is the new position of the ith element, pj is the new position for the jth element, pi is j, and both elements are smaller or larger than pivot. Wait, so they give me a pivot. Okay. My question is, if we have a pivot and we're trying to put everything less than it, does it matter the order? So 9, 5, 3 are less than 10. And then we have 10. Then the greater numbers are 12 and 14, going from left to right. Okay, this is 10 to the 5. I mean, I know a very simple solution to this, but I guarantee it's not great. It would be sort of what, an O-Vin solution? Relative order is obviously maintained. Ah, man, I do not want to do it this way, but I'm going to do it because I think it works. Okay. So we have our pivot, which means we can just scan the array. I don't even need to do that. If in is less than pivot, result.pushback. If in is equal to pivot, and it's greater than pivot. Yeah. I mean, this is really terrible way of doing it, but it maintains the order. It's at O of n. The only thing I'm doing is having more space. And I'm pretty sure O of n is going to work for 1,000 numbers. Yeah. Oh man, that is a simple solution. That cannot be what they expect for a medium problem, though. I think the best thing to do is to have, because I think this can be done in, see, this is done in basically 3n, because we're going through each element 3n times, right? But what we could do is we can do something like this. Nums dot size doesn't matter. Then we can go in I equals 0, i's or j equals 0. Yeah, j equals 0. Int center. No, let's just say j. Well, realistically, we can fill the min places first, right? This is smaller, keep it. This is larger, we swap. Hmm. The question is, where is pivot? The pivot does not maintain the same position. But we need the count of all the smallest values and the greatest values, right? Of course, for greatest, I could do it in reverse order. Of course, I could just scan it for the smallest positions first. Then scan it for the largest positions over pivot. And then the rest is pivot. Which would be the same thing I'm doing here. But it would be in place, right? Okay, let's try something like that. I'm just going to go int if nums I is less than. Would that work? Hold on. So if we're starting at 9, we say this position is for 9. Okay, then we hit here. This is too big. Then we hit here, we swap with this. Okay, is less than pivot. Then we want to swap it with the current nums j, right? Swap nums I, nums j. Okay, then we want to go j plus plus. And this will get us all the small values. And will also tell us where the pivot starts, right? Int mids. I'm gonna say if this will tell me the number, yeah. Nums I equals pivot. Mids plus plus. So if you land here, we can just continue. Just continue. Nine. That stays. Or no, technically, I'm going to swap with itself here. Then I'm going to go here, which is 12. I'm going to continue. Then 5, so I'm going to swap here and here. 10 is a mid. 14. And 3. 3 is going to swap with 12. Oh, wait. That's not going to work. How do we maintain the order? Can I do maintain, or... If nums I is less than pivot, I want to put it here, which is my small ones. That's not going to work. Hold on. I think I want the count. If I have the count, it'll be easy. Let's see. I can do something like this. Plus int greater. Yeah, that's what I'll do. If it's less, we'll go less plus plus. I is greater than pivot. Go greater plus plus. right? Which will tell me the number, right? Then I can just go for 0 is less than plus size, plus. No, actually, I'm going to do this auto. Should I do it like that? No. We have less and greater than. So I'm going to go int I equals 0. J equals 0. Actually, let's go K. I like it this way better. If nums I is less than pivot. Okay, so if the nums I is less than pivot, I want to swap this value no. I'm overcomplicating it. Right? Okay. I think I'm just going to keep this one. And then I'm going to think about this more later. Okay, well, you just saw me sitting here for like 10 minutes for no reason. Sorry about that. Yeah, just continue thinking. Let's go ahead and look at the topics. 2-pointer. This is not utilizing put 2-pointer. Simulation and array. What are they saying? Could you put the elements smaller than the pivot and greater than the pivot in a separate list, as in the sequence that they occur? I did that here. With the separate list generated, could you then generate the result? I mean, we don't need to if we do it like this. Oh, I see what they're saying. I guess instead of doing it like this and just going through the list 3 times, I could go through it once, get the last pivot or last mid greater if I wanted to. Because we could just append the vectors. I guess that would save some time, right? So what they're asking me to do is this. Int less int mid vector int greater. I don't even really need mid. It could just be an integer, right? Mid. Then they want me to go through and be like, oh no, I don't even do this. I can go auto. Because the indexes don't matter, right? So we can just say if n is less than pivot, let's stop push back. Yeah. If n equals pivot plus plus. Yeah, I'll just say else. Else. Well, technically, I could just do this. Results. And then I go last stop again. And then the result dot append. Oh, wait, no. First, I need a for loop. For 0 is less than mid. Push back. Result append in, and pretty sure I can just append it, right? No? They don't want me doing that? Is there no append for vector? One second. I'm just gonna look it up real quick. Capacity, element accessors, modify. Oh, they use insert, not append. So we could say we want to insert result.end. And then, yeah. Yeah. Technically, we can do this. Is it faster or more efficient? I don't know. Well, it's definitely not faster than my original solution. I wonder if it's because I use 3 different ways of doing this. $14 ms, 137. This is based on their hints too. I don't know if I like this solution. I think my approach of trying to have like a starting position and then the pivot section and the end section might have worked. So if it's less than, we want it in this section. The problem is, how do we guarantee by swapping? I don't know. Let's go ahead and look up the editorial, see what they say. Dynamic list, less than equal. Less equal greater. Yeah. They just straight up insert them into lists. 2 passes with fixed array. Less equal. Okay, so they're counting the number of less and equals. Yeah. We were already kind of doing that. 2 pointer. Less index and greater, which track the position where the next smaller and larger element should be placed, respectively, as we iterate through the array from both ends, using I for the left to right pass and J for the right to left pass. I mean, yeah, this is kind of what I was thinking about having sections. Yeah. Okay, well, um, that's the solutions they had. There's the solutions I had. Thanks for joining in for today. I hope you enjoyed the content. If you did, subscribe. If not, leave a comment or whatever. And I hope you have a wonderful evening. Peace.